Dear students, as you know that we have already gone through chapter 1st of our economics course for the class 12th, in which we have gone through the introduction of economics and the most important concept, that is the production possibility curve or the frontier. Today I am here going to start up with the second unit, that is consumers equilibrium. Consumers equilibrium. Under this chapter, we have got many topics which we are going to cover in relation with each other. Consumers equilibrium. Here, now we are going to look into the matter that how a particular consumer, that is the last element of the three functions, most important functions in economics, that is production, distribution and consumption. The last element, that this is consumer. How this consumer is going to be satisfied. How this consumer is going to attain this equilibrium, the state of rest, where he is able to maximize his satisfaction. So, starting this unit, I'll start with the concept utility. Utility. This utility is as well known as the benefit or the value. Every consumer is able to make a judgment that where and how he is going to satisfy his wants. And this utility is as well the want satisfying capacity of a commodity. That simply means utility is something which satisfies the wants of a consumer. That is the want satisfying capacity of a commodity. Now there's a problem. How we can measure something which is psychological? How we can measure something which we cannot take into the numbers? So, there are two approaches to study it or to understand it. One is the cardinal approach, another is the ordinal approach. Under cardinal approach, which I am going to take up here, we study it through the utility concept, where we impart, where we psychologically, hypothetically give numbers to the units or numbers to the levels of our satisfaction in, say, 1, 2, 3, 4 and so on, the cardinal numbers we take. The second thing is that we are going to take up these cardinal numbers to make the things happen and understand how this utility, how a consumer gets benefited, how he values a different set of commodities. But the thing here is that we are not going to take the two commodity case here, we will be taking a single commodity case. Now, understanding this utility, what this utility means. Utility simply is the want satisfying capacity of a commodity that I said earlier. How and why? So I'll be taking here an example. Suppose I am taking a particular quantity. This quantity is of chocolate bars. Chocolate bars. There is a limit I can consume. How? Like, let us see. First unit, second unit, third unit, fourth unit, and so on. We can take many units. Second thing which I am going to discuss here is the utility derived from consuming each and every successive unit. This will be discussed in two basic themes or two basic components or concepts. Number first is the marginal utility, and second is the total utility. So, what marginal utility is all about? Marginal utility is the utility gained after consuming each and every successive unit. A single unit, what the utility it imparts, how it satisfies, is under the marginal. Marginal, the unit change. This change could be negative, this change could be positive. Here we are talking about the utility, that how each and every successive unit consumed imparts the utility or satisfaction or increases the utility of a consumer. Likewise, the total utility. The concept of total utility is something how the extra unit consumed from a consumer imparts the utility in totality to a consumer. The total satisfaction from consuming a commodity by a consumer. The total satisfaction. How if I am, say, consuming an apple. I am consuming an apple and it is imparting a utility of 1 unit to me. Now I am consuming the second apple. If it is imparting, say, the 10 utils of utility, here comes the thing. What I have to talk about is that the utility we measure in utils. We have no particular yardstick to measure utility. So what we do, we measure it in cardinal numbers, that is 1, 2, 3, 4 as I said, and we measure it in utils. So here I am going to start with the concept now. So quantity, I have taken 1, 2, 3, 4. These are the units of any commodity I have consumed. I am going to consume. Being a consumer, I am going to consume, and I have named it as the chocolate bars. When I will consume the first chocolate bar, it is going to give me utility, it is going to impart me some utility. Suppose it is going to impart me 100 units of utility. Say I'll call it marginal utility, because I am here evaluating it in units. I am going to evaluate it on the unit basis. The unit changes I am going to take into consideration. So the first unit will impart me 100 units of utility. 100 utils of utility. What will happen? While I will consume the second unit of the chocolate bar, while I will consume the second chocolate, what will happen? That I won't be able to maximize the utility, but the utility will come down a bit. Why? Because if I am thirsty, I'll take a glass of water. My thirst is gone. Now, taking the second glass of water, if I am taking it now, it is not going to give me that much of satisfaction as the first glass of water will give to me. So what will happen? The utility will come down a bit. Utility will diminish a bit. Utility will be decreasing a bit. So the first unit will give me the 100 utils of utility. The second may be 90 utils. The third may be likewise 80 utils, and the fourth respectively the 70 utils. If I am increasing the consumption of chocolates, I'll come to the fifth unit. It will impart me 60 units or utils of utility only. Now, as I said, the marginal utility simply says that each and every successive unit imparts a utility. We are counting here the each and every successive unit, how much utility it is imparting to me, and against it the total utility. Total utility, what it is? Total utility is the sum total of the utilities derived from all the units I have consumed. So I can numerically say that marginal utility is equal to total utility at the nth unit minus total utility at the n minus 1th unit. How come? Here a problem arises with the students many times that they are not able to understand that what this n is, this n minus 1 is. This n is a particular point of time. N is the particular point of time. Suppose when we talk about the time, we talk about 3 times respectively: the present time, the past time, and the future time. So we won't be taking future time into consideration much here while we are understanding the utility, the marginal utility or the total utility, because we are consuming something and we have consumed something. So we'll be taking the present and the past into consideration. This n will represent the present consumption. This n minus 1 will represent the past consumption. That means this n minus 1 is the past, this n is the present, which we are going to talk about. So while talking about the utility, I am talking about the marginal utility. Marginal utility is the total utility at n minus the total utility at n minus 1. So if we would talk in case of this schedule which I have made here, you will be able to find out that if I will calculate total utility from this table only now. The total utility, how total utility will be calculated? This is total utility at n, that means total utility at n is here 100. And minus total utility at n minus 1. Total utility at n minus 1. We don't have consumed any unit in the past, so it is 0. 100 minus 0 is equal to 100. So total utility here is 100 only. So taking into consideration this very element, I have consumed the first unit, the first chocolate, and I am able to derive 100 joules of utility from it. Likewise, when I am talking about the total utility here, the 100 as it is here, now I'll be coming to the second unit. The second unit will be imparting me some more units of utility that will get added to this utility, that is the total utility. How come? Again, the total utility at n minus total utility at n minus 1. How come I will be able to evaluate it? Now total utility at n is 90 here. And total utility at n is 90 here. I'll add it like this. The total utility at n is 100 units and the total utility at n minus 1 is the 90 units. That is 100 plus 90 will be 190, like this. So on and so forth, because we are going to take this concept into consideration once more. So students, how a consumer will be able to maximize his utility? Utility in the sense that he is able to get maximum out of what he is spending in the market. So while I am talking about the spending, that is the money, we can talk about the marginal utility of money. The marginal utility of money is nothing but the quantity consumed and the price given for it. That is marginal utility of these C indicated the chocolate bars divided by the price of these chocolate bars. We can take the second commodity into consideration, but here we are dealing with a single commodity case. So marginal utility, whensoever we are going to talk about the marginal utility of anything, that is the unit change. I am here talking now about the marginal utility of the chocolate bars I am consuming and the price of chocolate bars. What will be the marginal utility of money for me here in case of these chocolate bars? Suppose every chocolate bar I am getting at the $2. I'm spending $2, then I'll be able to get a unit of the chocolate bar. The marginal utility derived is 100. So it is so simple that marginal utility of the chocolate bar divided by the price of the chocolate bar, that is 2, is equal to 50. So the marginal utility of money here for this first chocolate bar consumed is 50. Likewise, here it will be 45, so on and so forth. This is a very simple math. That means I am getting the best band or best bang for my bucks. Every consumer wants to have the best out of the best. Every consumer wants to satisfy his utility, wants to satisfy his wants. That's why I started with the utility, which is the want satisfying capacity of a commodity. Now the second, students, will come upon the major concept or the component of this utility type. We have gone through the marginal utility, the total utility. Now we'll talk about a schedule and some graphical proportion in between the marginal utility and the total utility, and we'll be now able to show graphically how marginal utility and total utility are and what it is all about. Then we'll be able to establish a relationship in between the two. So I'll take a simple schedule here which would just be which would just suffice me and this class to understand how graphically the marginal and the total concept of utility looks like. So I'm going to take up a schedule like this. Consumption of a commodity. Again, that units of commodity I am talking about. The total utility derived from the consumption of this commodity, say we will name it X, total utility of X. The third, we can talk about the marginal utility of X, and as I said that we can derive marginal utility from the total utility and we can derive total utility from the marginal utility. The concept here is how I am consuming successive units of a particular commodity, apple, tea, water, banana, anything, and how my total utility is increasing and how every successive unit is giving me the addition of a particular want, addition in my satisfaction. I am consuming the first unit, say 0. I am starting it from 0 in order to understand, to make you people understand that how graphically this 0 will matter. Otherwise the curve will start anywhere else. This is the first unit I am consuming. So the total utility here will be as well 0. There will be no marginal, no addition in the units. Second unit I'll talk about is the first. When I'll consume the first unit of this commodity X. Suppose it gives me a total satisfaction of total utility of 100 newtons. As we know, there is nothing to calculate. There is nothing that marginal utility, as I said, marginal utility at nth unit is equal to total utility at n minus total utility at n minus 1. So here is nothing, so the marginal utility will be 100 as well. Second unit it is now a bit interested. Second unit, so when I am consuming the second unit, it is imparting me a total utility of 190 utils. That means the 100 utils from the first unit and the addition of 90 utils from the second unit. Why it is only 90? Why it is not 200 exactly? That is to be established under a law that we will talk about later, but still for the time being this is 190 utils. So when we say the marginal utility, now it is very easy to establish according to the marginal utility of nth unit is equal to total utility of nth and total utility at the n minus 1 unit. So it will be 190, that means it will be equal to 90. When I'll talk about the third unit now, the third unit will be able to impart me just some more, say 80 units. When I'll add 80 units to 70 utils of utility, total utility of 270 utils of utility. Accordingly, here I'll be able to get 80 utils, the marginal units. The marginal utility is the addition in per unit. I'm talking in the unit change. This unit is changing 80. Likewise, if I'll talk about the fourth unit, the fifth unit, I can talk about many units. I'll talk about the fourth unit, it will impart say 340. It is arbitrary, it is just the psychological law which we are establishing here with hypothetical data taken into consideration, where we are assuming that a consumer is able to. Understand this thing properly. The consumer is able to impart a cardinal number to the satisfaction he has derived. This is very important thing which we have to understand here. So likewise, it will come to 70 here, and at last I am going to take 400 at the fifth, and this will come to 60 here. So this is the schedule of the total utility and the marginal utility. While I was saying marginal utility, now we can say total utility is equal to the summation of the marginal utility. Total utility is equal to the summation of the marginal utility. How come it is? See, now I will see total utility is equal to the summation of marginal utility, that is equal to 100 plus 90 plus 80 plus 70 and plus 60, so on. I can put it into, but I have taken just 5 units to make you people understand. So I am stopping here. That is 100 plus 90 plus 80 plus 70 plus 60. It's a very simple math, will come equal to 400 utils, 400 units, and likewise it is here the last element in the total utility is 400 utils. Now graphically, how we will be able to apply this these simple numerical aspects to a graph. What in graphics we do, as you have got introduced to graphics in the last lectures, and in microeconomics, the graphics has got really a very important place. I'll take an simple thing, this y-axis upon this x-axis. Why I had taken this 0 here will be established here, because I am going to start from the origin. And in x-axis, I'll take consumption of commodity X, and at y-axis, I will be establishing the total utility of X and the marginal utility of X. If I would look at the total utility, the highest element in total utility, the highest numeric in total utility is 400. So I'll have to take at least 400 here in order to establish this. So I'll start with the units of 50, 50, 100. With the difference of 50, it will suffice 150, 200, 250, 300, 350 and 400. This will complete that. I am having now 400 utils to show here. Now I am taking the commodity consumed, the units of commodity consumed, that are 5 only. I'll divide this line into 5 equal parts. That is the first unit, the second unit, the third unit, the fourth unit and the fifth unit. This will suffice us. So what I am establishing is the how total utility curve. I am using the word now curve. The total utility curve and the marginal utility curve look alike. So what is the first unit? That is 0, 0 and 0. So I am getting a point here. What I am going to draw first is the total utility curve. So the first unit imparts 100 utils of utility in the total aspect. So the first relates to 100. I am going to join the two. It's a very simple graphic proportion. As you know, we have been doing it lately like this. Second is 190. I am going to take the second unit is here. it is going to reach to 190, say 200 is here, 190 will be somewhat below here. I'll extend this line like this, and I'll extend this so that it may meet somewhere. It's meeting, the meeting point of the two is here. Likewise, the third unit is on the 190 is gone. Third unit to 70. Third unit to 70. This is 350 to 70. Must be somewhere below 300. Like say here. I'll extend this as well so that they may meet somewhere. This meeting point, this equilibrium point, this stationary point, what we are looking for. And we have gone through the third unit, the fourth unit, 340, fourth unit, I'll extend this fourth unit like this. 340 will be somewhere, say like here, 10 units short of the 350. So I am here. It is now a bit interesting. It is what microeconomics is all about. It is what we are looking for. It's what we are going to establish here. The fifth unit will directly join with the 400th unit, which is the last unit, so we'll be able to get a point here. What we have to do simply is to join these points and nothing else. So for that reason, I'll be using some other color. Let us take this red marker, B, C, D, E. We can name these units as well like this: dash, A, B, C, D, E, dash, A, B, C, D, E. What we got here, dear students, is the total utility of X, or total utility curve. Now, I am going to draw another curve, is the marginal utility curve. What marginal utility is saying? 0 is with the dash, so 0 is with the dash. Leave it here. First unit is imparting 100 newtons of 100 newtons marginal in marginal utility section. So first is with the 100. So first is with the 100. I'll encircle now. This is my first. Second is the 90. Second unit, marginal utility 90 utils. So 90 will come somewhat below the 100, say here. So this is my second unit. Third is at 80. Third unit is here. 90 below 80, that will come somewhere here. Fourth util 70. 70 will be somewhere above 50, say here. And fifth util 60, that simply says this below this 50, that will be somewhere small, a bit higher on the x-axis. Now, when I am going to join these points, I'll get another curve like this. This is the marginal utility. You may not go, if you are getting confused while you are looking at these dots and curves, I'll simply transfer this XC without any name. I'll simply transfer this total utility curve. I'll simply transfer this marginal utility curve. Marginal utility curve is somewhat like this, marginal utility curve. And you may now able to see the how curves like total utility curve and the marginal utility curve look like. So this leads us to another component or concept, that what is the relationship in between total utility and the marginal utility. When we are talking about the total utility and its relationship with the marginal utility, we can establish it very simply on a very simple schedule and some simple graphics, and three things we will get through. Number first, these are three important or golden rules which we have to go through, which must come into context. Then only a relationship will get established in between the total utility and the marginal utility. Number first thing is, total utility will remain increasing. Total utility will remain increasing as long as marginal utility is positive. Total utility will remain increasing as long as marginal utility is positive. You must be thinking that sir said that when we were doing in the last graphics we were doing that there was no element where we got into the negativity or the negative side of the graph, but it gets into the negative side of the graph. One time, the first thing. The second thing, total utility will be maximum. Total utility will be maximum when marginal utility will tend to be 0. When marginal utility comes equal to 0, total utility will be at its maximum. Third and important relationship which must get established is that total utility starts declining when marginal utility becomes negative. We may add a few points to this schedule, or we may make a new schedule in order to understand it on a bit, not very much, a bit higher level, so that we may be able to establish a relationship in between the total utility derived from all the units consumed and the marginal utility derived from each and every successive unit of consumption. And we will be able to make a relationship, establish a relationship in between the two. Like, I will take a simple schedule here. Quantity of X. Now, I won't give any name to this X because you people know that what this X means. Say 0, 1, 2, 3, 4, 5 and 6. I'll take some total utility. You people know that how total utility gets established, how it is being evaluated. So there's no need of describing the things how I am taking it. So at 0 it will be 0. First unit say imparts 8, 14. I'll be taking some hypothetical data again in order to make you people understand how this will increase. Say from 0 to 8 there are 8 units. From 8 to 14, there are some around 6 units. I'll be increasing my consumption like to 18, say 20, say again 20. This is very important. You must be able to understand this very portion here. And from 20, it will come to 18. What I said? Total utility is increasing. Total utility is maximum here. And total utility is declining. Let me show it. Total utility from here to here, it is increasing. Dear students, this type of arrow, in economics, we use to show the increasing nature of anything. Total utility here is maximum, MAX, and total utility here, so after this maximum unit is declining. 3 phases. Second thing we are going to talk about is the marginal utility. The marginal utility, as you people know, is nothing but the total utility at the first place and the total utility at the n-1, that means before the first place what we have consumed. So it will be 0 here. Total utility will come 8. I don't have to establish it time and again, so I'll be just going through it in order to establish a relationship. So it will come to this minus this will come to 6. 18 minus 14 is equal to 4, and 20 minus 18 2. 20 minus 20 will come to 0. This is very important for you people to understand here. Now it becomes 0, and when 20 minus 18 will come into context, what will happen? It will now tend to be negative. Got it? 14 minus 18, 18 minus 14, 20 minus 18, 20 minus 20, and this 18 minus 20 is equal to minus 2. Now it tends to be negative. I'll come graphically upon it and establish the 3 golden laws. Suppose this is the first graph I am going to take. I have to go to the negative side as well, so I'll be taking them not together. First graph I'll use to show the total utility. When I'll draw the total utility curve, it will be somewhat like this. This is the total utility. When I'll draw the marginal utility curve, it will start somewhat here. Say this is the 10th unit. Dear students, look at this. 10th unit. From 10th unit I am going to start it, and it will tend to be negative as well. It is maximum here. You extend it like this. Now see, this is my total utility curve. When you will draw it on these numericals, these curves will be exactly like what I am showing here. These are the 2 origins. Now see, first, what is the first golden law? The total utility increases as long as the marginal utility is positive. Marginal utility is positive, total utility is increasing. Second thing, total utility will be at its max. Total utility is maximum when marginal utility is 0. This is the point. Total utility is maximum, marginal utility is 0. Sorry, this is marginal utility. Total utility is maximum, marginal utility is 0. See how? Total utility is maximum, marginal utility is 0. Third and important most thing which we have to talk about is total utility starts declining when marginal utility is negative. Total utility starts declining. This is a declining portion of the total utility. This much. When marginal utility is negative, this is the negative part of the marginal utility. See, all the 3 establishments got established. The last but not the least, what we are talking about here in the context of utility is the law which we have to establish. That is called the law of diminishing marginal utility. This is the word I was just craving for, that when I'll be using it, because utility is all about that as more and more consumption of any commodity is increased, as more units of that commodity are taken, the intake of the commodity decreases. How? This law is again a cardinal law which I am going to talk about, because it has been put forth by Alfred Marshall in order to show the psychological state of a consumer and how consumer is able to satisfy himself in the scarcity. You must be remembering that economics is all about scarcity, the most prominent and the latest definition. And it is all about optimality, how you will obtain your optimal point and you will maximize your satisfaction. Alfred Marshall put forth this law of diminishing marginal utility. This is as well called the fundamental law of satisfaction. and some people may call it as psychological law of utility or satisfaction. So dear students, what law states? There's you must note that every law has got a statement, and this law states the law of diminishing marginal utility states as more of a commodity are consumed, marginal utility derived from every additional unit consumed declines. So simple the law is. As more and more units of a commodity are consumed, the marginal utility derived from every successive unit declines. As we established earlier through graphics and all, I can again show you a small schedule here. Quantity of X consumed 1, 2, 3, 4, 5. The total utility derived from this, what we have to establish? The marginal utility, the diminishing marginal utility. As we will increase more and more units of a commodity, the utility derived will diminish. We have to establish only this very thing. The total utility imparted here will be, say, 10, 15, 20. I am now increasing it at a particular rate. There are two rates which I was talking about. Either increasing rate, something increases at an increasing rate from 100. If it comes to 210, then 300 to 20, it is the increasing rate. Something increases at decreasing rate, and that happens to the marginal utility as well. That is very important to understand here. Say marginal, I'll show you here the marginal utility. 25, first unit, second unit, third unit, fourth unit, and 30. I have taken the 30 total utility as 20, 20, I'll cut it short here, 20, 20, and 18. When I'll talk about the marginal utility here, from 18 it may reach to 16 on the 6th unit, from 16 it may reach to 13, 7th unit. The marginal utility here, as you know, the marginal utility is total utility at n minus total utility n minus 1 will be like 10, 5, say 5 again, 0, minus 2, minus 2 again, and say minus 3. 10, 5, 5. We may change a few numerics in order to establish it properly. Say from 10 to 15 to 18. Here we will get 3. From 18 to 20 we will get minus 2. We will put a 20 here, so we'll be able to get a 0. And likewise 4, but in minus. 16 to 13 is minus 3. Fine. Marginal utility. The law states as more and more units of a commodity are taken, the utility derived from every successive unit declines. How? Because this is the psychological motion. Persistently, when you will increase the intake of any commodity, it is obvious that you will get fed up. Like I'll repeat the example. Say I'm taking the chocolate bars. Chocolate bars are something, when I'll consume the first one, I'll be very happy. Yippee. The second one won't make me that much happy as the first one. The third one, successive units, will decrease my utility. Here gets the law which we are using here has only two basic assumptions. Only two basic assumptions. Number first is only standard units consumed. What does it mean? It means I am consuming a cup of tea, it's a standard unit, not the spoons of tea I'll consume, then this law will never get established, because I'll be able to consume many and many spoons of tea. So only standard units must be consumed. Number second is consumption of commodity is continuous. What does it mean? It is not that I am taking a cup of tea now and I am taking the other cup of tea tomorrow. It won't happen. The law won't get established. It must be continuous. I am taking it now, and as soon as I am completing the first cup of tea, I am taking the second cup of tea. As soon as I am completing the second cup of tea, I am taking the third cup of tea. Then only this law of marginal utility, the diminishing marginal utility, will get established. As I said earlier, Alfred Marshall has stated it. It is in the cardinal approach. So a simple graphics about it, and it will complete. Say this is our y-axis upon x-axis, y, x, O. Dear students, whenever you will write an exams, you will go through exams, do not ever forget to indicate these small postulates like y, x, O for origin or 0, because these are being counted. So now when I am talking about the marginal utility here, this marginal utility curve will be somewhat like 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And what are the units? Marginal unit it is a 10th unit, the highest. Now let me divide it like this. When I'll draw this marginal utility curve, what it will look like? It will be like this. At the 5th unit, it is 0. After 5th unit, it tends to the negative portion. Now look. This portion is decreasing, of course, but is positive. This portion is negative. I'll extend this. This is in the minus category now, and here it is 0. The law is established here that as soon as more of the units of any commodity are taken, the marginal utility derived from every successive unit declines from first to second to third to fourth to fifth, from first to second to third to fourth to fifth. At fifth it is 0, and after that it declines. So it completes the utility part, marginal utility, total utility, and the law of diminishing marginal utility. Thanks a lot.